This is an example of how to find the Laplace transform for a step function. So if we want to find the Laplace transform for the step function u5 sine of t, and in this case I want to use this theorem in order to find the Laplace transform. So this theorem says the Laplace transform of a step function uc of f of t equals to e to the negative cs multiplied by g of s, where g of s is a Laplace transform of the function f of t plus c. Okay, you have to shift the function f of t to the right c unit. That means f of t plus c. So we have these functions, and we know that u5, that means 5 is a step unit, right? Then you finding the Laplace transform of u5 sine of t. First, we can come up with the first term, which is e to the negative 5 times s. And then the next thing is we have to find g of s using the function f of t. And we know that the function f of t is sine of t. Then f of t plus 5 will be sine of t plus 5. And using one of the trigonometry identity, we can find sine of t plus 5 equals to sine of t multiplied by cosine of t, cosine of 5, plus cosine of t multiplied by sine of 5. Alright, and as keep in mind that cosine of 5 and sine of 5 are just constants, while sine of t and cosine of t are a trigonometry function. So the next step is, again, we want to find the Laplace transform of sine of t plus 5, which is sine of t plus 5, right? And using this long expansion definition. So that means we have to find the Laplace transform of this expression instead. And we know that the Laplace transform of sine is 1 over sine of t is 1 over sine squared plus 1, and you multiply by cosine of 5. So this is the Laplace transform of sine of t multiplied by cosine of 5 here. And then we know that the Laplace transform of cosine of t is s over s squared plus 1, and that means you just need to take s multiplied by s squared plus 1 multiplied by this constant sine of 5. So again, the Laplace transform of sine of t plus 5 equals to this expression here. You have cosine of 5 divided by sine squared plus 1 plus sine of 5 multiplied by s divided by s squared plus 1. Okay. Putting everything together, we know that this is g of s. Again, g of s is the Laplace transform of f of t plus c, and f of t is sine of t. That means f of t plus 5 is sine of t plus 5. And if you find the Laplace transform of sine of t plus 5, that is the function g of s. Put in the formula, we know now we can find the Laplace transform of u5 sine of t equals to e to the negative 5s multiplied by this expressions. Again, we've just found the Laplace transform of a step functions that involves trigonometry functions using this theorem.